Welcome to the M-class stars, the cosmic couch potatoes of the universe. These are the red dwarfs, the smallest and coolest stars out there, barely pushing their surface temperatures past 3,500 Kelvin. Think of them as the cosmic equivalent of that one friend who never leaves the couch but somehow still dominates Netflix binges. Their faint red glow is more like a dim nightlight than a spotlight, illuminating their tiny cosmic neighborhoods in quiet humility. Proxima Centauri, the closest star to our Sun at just over 4 light-years, is a prime example. So faint that fooling your eyes into spotting it without a telescope is basically a cosmic prank. Then there's TRAPPIST-1, famous for how it hosts 7 Earth-sized planets in a cozy orbit, proving you don't need to be flashy to be interesting. These tiny stars burn their fuel at a snail's pace, which means they have lifespans lasting trillions of years, longer than the entire current age of the universe. Despite their unassuming performance, M-dwarfs dominate the stellar population by sheer numbers, quietly holding the galaxy together while the flashy stars hog the cosmic stage. Their low energy output means they might not be the universe's hottest party animals, but they're the steady background hum to the cosmic symphony. So, the million-dollar question: how does the cosmic party heat up when we leave these cool couch potatoes behind? Let's crank that stellar thermostat and find out. Next, we move to the K-class stars, the dependable middle managers of the cosmic office. These orange dwarfs are warmer than the M-class, with temperatures ranging from about 3,500 to 5,000 Kelvin, and emit a soft orange glow that says, "I've got this." They're the stars that quietly boost the energy a notch without wanting to steal the show. Epsilon Eridani is a classic example, nearby at about 10.5 light-years, emitting enough energy for its orbiting planets to enjoy a steadier shine without the drama. Alpha Centauri b, part of the closest star system, balances its energy output perfectly. Stable and long-lasting, it knows how to keep the peace with its stellar siblings. These stars are the unsung heroes when it comes to durability. They live longer than hotter stars, yet shine brighter than M-dwarfs, providing a sweet spot of energy and longevity. Their steady brightness creates dependable environments. Think of them as the cosmic equivalent of having Wi-Fi that doesn't drop during a crucial Zoom call. K-class stars have the stability necessary to potentially host planets with life, acting like nurturing cosmic landlords. But what if a star wanted more than a steady desk job and aimed for the executive suite? Ready to discover how the heat and status rise with our next stellar candidate? Here come the G-class stars, the cosmic Goldilocks. Not too hot and not too cold, but just right. These yellow dwarfs boast surface temperatures between 5,000 and 6,000 Kelvin, perfect for bathing planets in steady, life-supporting light without scorching them to cosmic crisps. Our very own Sun proudly wears the G-class badge and serves as the stellar superstar that makes life on Earth possible. No small feat in the grand cosmic game. Alpha Centauri A, the Sun's neighbor and sibling, shares this status as well, a testament to the class's reputation for balance and reliability. G-class stars provide a long and steady energy output that sustains complex life forms and ecosystems for billions of years. Their habitable zones, the sweet spots where liquid water can exist, are the real estate gold mines of the galaxy. Spectroscopically, these stars show a strong presence of hydrogen and metallic elements, signaling balanced stellar atmospheres ripe for steady fusion. They're the stars that casually remind you, hey, if you're here, that's probably because of me, without needing to shout. Their mystery lies in how their moderate temperament allows the chaos of life to bloom in harmony. Yet, what happens when a star decides that being just right isn't enough, when it craves brilliance and power? Time to turn up the heat and meet the ambitious stellar next in line. Brace yourselves for the F-class stars, the ambitious overachievers who blaze brighter and hotter than their G-class cousins with surface temperatures from about 6,000 to 7,500 Kelvin. These white dwarfs are the cosmic interns who show up early, leave late, and get noticed, even if they don't always get the corner office. Procyon A is the quintessential F-class star, only 11 light-years away, radiating enough energy to make planets orbiting it bask in brilliant, albeit often challenging, stellar light. Canopus, another F-class luminary, is a giant star often mistaken for a planet due to its sheer brightness, lighting up the southern skies with a cool intensity. These stars have shorter lifespans, several billion years compared to the Sun, but make up for it with a more intense energy output, radiating significant ultraviolet radiation that can both nurture and threaten potential life. Their spectra present strong hydrogen absorption lines mixed with ionized metals, revealing their atmospheric complexities. F-stars are like the go-getters of the galaxy, eager to shine and make an impact, but their hyperactivity comes with a catch: shorter stellar lifetimes and more challenging environments for life to take hold. So what happens when a star demands the spotlight and outshines even these energetic show-offs? The next star on our list is already burning a hole in the galaxy's sky. Welcome to the A-class stars, the celestial rock stars known for their dazzling luminosity and surface temperatures soaring between 7,500 and 10,000 Kelvin. These white-blue dwarfs are not just stars. They're cosmic celebrities lighting up the stellar runway with a flare that's impossible to ignore. Sirius A, the undisputed brightest star in the night sky, is the prime example. A stunning, brilliant source of light that demands attention anywhere on Earth. Vega, once the standard for stellar brightness calibration, is another A-class star, shining with charismatic intensity in the northern summer skies. These stars burn hot and bright, providing intensely energetic radiation that shapes the atmospheres and environments of any nearby planets. But their dazzling luminosity comes with a cost. Their lifespans are relatively brief, lasting hundreds of millions to about a billion years, which is a blink on the cosmic timeline. Their spectra showcase strong hydrogen absorption lines, marking the youthful vigor that defines them. To planets orbiting them, it's like trying to survive a non-stop laser light show at a rock concert. Exciting for a moment, but hardly a stable place to call home. A-class stars broadcast their brilliance with magnetic charisma, demanding respect but also indicating the fleeting nature of such stellar fame. So what's the next level when you want to transform from a celestial rock star to a full-blown cosmic powerhouse? Let's find out. Welcome to the realm of B-class stars, the galactic heavy hitters that crank the heat up to between 10,000 and 30,000 Kelvin. These blue-white giants are the cosmic powerhouses that really know how to steal the show. Rigel, the dazzling jewel of the Orion constellation, is the textbook B-class star, blazing so brightly that it outshines entire star clusters with ease. Spica, the brightest star in Virgo, is another B-class champion, pulsing its intense energy through the galaxy's veins. These stars live fast and furious, burning through their nuclear fuel in mere tens of millions of years, a fireworks show that ends all too quickly. Their ultraviolet radiation is so intense that it shapes surrounding nebulae into magnificent glowing clouds, creating cosmic art observable even with modest telescopes. Spectrally, B stars flaunt strong helium lines alongside hydrogen, reflecting their extreme temperatures and fierce internal pressures. Planets basking in their radiance would need to be tough cookies, protected from the relentless barrage of energetic particles and radiation. B-class stars are the cosmic adrenaline junkies, living life in the fast lane, pushing the limits of stellar endurance and awe. But even that wild energy isn't the end of the cosmic story. There's one more level to go. Now we reach the O-class stars, the ultimate cosmic superstars, blazing with surface temperatures exceeding 30,000 Kelvin. These blue giants are the hottest, most luminous stars in the universe, radiating energy so intense it can strip electrons from atoms and sculpt entire nebulae with their stellar winds. Zeta Ophiuchus is a classic O-class star, a runaway giant hurtling through space at breakneck speed, its fierce light cutting through the darkness like a cosmic spotlight. Eta Carinae, another O-class titan, is famous for its violent eruptions and the spectacular homunculus nebula it created, a cosmic fireworks display that astronomers still study today. O-stars live fast and die young, burning through their fuel in just a few million years, a blink in the cosmic timeline. Their spectra are dominated by ionized helium and heavy metals, revealing the extreme conditions within their cores. These stars are responsible for some of the most dramatic events in the universe: supernovae, gamma-ray bursts, and the creation of heavy elements that seed future generations of stars and planets. While their environments are far too hostile for life, O-stars are the architects of galactic evolution, shaping the destiny of galaxies with their explosive brilliance. If the universe held a talent show, O-stars would be the grand finale, leaving everyone breathless and wondering what could possibly come next. If this journey hasn't made you look up at the night sky with a newfound respect, or at least made you question why stars are so dramatic, then I might have to send an angry letter to the universe for wasting your time. If you enjoyed hitching a ride on this stellar staircase, please drop a comment, crush that like button, and subscribe to CosmoBinge for more space wisdom with a side of sass. Because if there's one takeaway, it's this: stars might live fast or slow, be hot or cool, but they all shine in their own wonderfully ridiculous way.